All right, so let's get started. Okay. So I put the video on YouTube, so you should be able to access. I don't think it's very perfect, but I guess you can refer to that later on if you need to. Okay. So all right. So what we're gonna do today is kind of finish what was left from previous lecture, and then after. So we have two more slides. I think two more slides from the first lecture, and then after we'll start talking about grammars. Okay. Right, and then we look at. I think we can look at some examples too. Okay, so all right, so this is what we kind of left off, right? In the previous class, right? So now, so we kind of went over basic introduction to automata theory, right? And then we kind of talk about alphabet, right? And then strings and things like that. So so a language is it? So first we start with alphabet, right? So using the alphabet, you can basically get strings, right? By simply combining those alphabets, right? Or I guess the letters in the alphabet, right? And then so from the strings, you basically get a language, right? So a language is simply a set of strings, okay? Now, so later on, what we're going to talk about is basically okay, how do you define a set of rules that you can use to generate a language? Okay, but right now we're just talking about the definition of language. Okay, now okay, so let's go over this slide. Okay, once again, so we went through this in the previous lecture, but let's go through this again. So all right, so language is simply a set of strings, okay, which you can basically generate over an alphabet, over a given alphabet, right? So for example, let's say if you have an alphabet which is denoted by say uppercase A, right? Now the set of all the strings over A is basically denoted by A asterisk. So what does that mean? So remember we did this, right? So let's say you have say alphabet A is, let's say letters, right? Let's say A, B. Okay. So now A, this is what? So we have something like this, right? Something like this, right? So you can basically generate. So A to front will be simply an empty string, right? And this would be what? This would be the string of length 1, right? That's why we described this. What would this be? All the strings of length 2, right? All the strings of length 3, right? So you basically take the union over all the strings, right? Then you simply get this, right? Okay. Now, how you actually get each of this is basically using the letters in the alphabet, right? Okay. For example, for this one you can get what? A or B, right? This one you can get AA, AB, say BA. What else? AB, right? Right. So with this, you're gonna have three different letters, right? So say AA, AB, so on and so forth, right? Okay. Okay. So now over here, so okay, so here, so you A asterisk, right? So this is basically, so this can be one language, okay, over the alphabet A, right? But you can also define different languages over the same alphabet. Okay, for example, say you can simply have the empty set, which simply means there's nothing, right? That means you cannot define any language out of using that alphabet, right? And you can also have a language which simply contains the empty string, okay, and then the alphabet itself, okay, and then A asterisk, okay. Now, okay, so now another way of basically defining a language, or I guess representing a language, is basically in the set format. So for example, like this, right? So let's say you can denote a language in this format. Let's say A B to the power n A, such that n belongs to a natural number, right? So that means lowercase n can be 0, 1, 2, 3, and so on and so forth, right? So so that means so this simply means what? The set of all the strings, right? Which basically starts with A and ends with A, right? But there's going to be at least so there can be 0 B's or I guess 1 or 2 or 3 or whatever B's, right? Okay. So like we discussed in the previous class. So a lot of times we'll be defining languages in this format, okay? So like so where you simply have an alphabet with, say, a couple of characters. Let's say in this case, the alphabet should be A and B. Okay. Now, so either a language can be denoted in this format, right? Simply like I guess a more elaborate version of the set, right? Or I guess a more condensed format of the set. Okay. Now, okay. All right. So today, later on, what we're going to discuss is, okay, how if we have a language like this, right? Can I basically generate a set of rules that allows me to basically I guess generate all the string which is in this language. Okay, so that's what we're going to discuss later on. Okay, but right at this point we just kind of going over some definitions associated with the language, right? Okay, all right. So one more definition. Okay, let's say the product of two languages. Let's say if you have two different languages, L and M, right? So L and M is going to be, say, so L. Let's say you have L over here, M over here, right? So again, there's going to be, so this is going to be a collection of strings, right? It's also a collection of strings, right? so the product, right? The product of these two languages is basically denoted by what? LM, okay? And this, so LM will be simply, again, a collection of strings, right? Okay. So now the way you define those strings is in this way. So you have, so you can define, so any string in that language, LM, can be denoted by ST, where S belongs to what? The first language, and T belongs to the second language. So that means if you take any string out of this language, right? So that string can be broken down into what? In the form of ST, right? Where S comes from the first language, and the second, and T comes from the second language. Okay. Now say, so we'll see some examples later on. Okay. So so again, so maybe we can look at some examples. So let's say if we have, let's say for example, let's say you have L equals, say, so let's say L is simply, say, let's say this is to A, B or something. Then M is, say, this is to, say, C, D or something, right? So you have, so L, M will be simply what? So you can first take what? A, right? This A. You have C, D, right? So A, C, A, D, and what else? B, right? B, C, B, D. Okay, so then if you take any string out of this language, right? So you take this, right? This can be broken down into what? So A, D, right? So A comes from what? L, and D comes from M, right? Okay, right? So basically I guess the beginning, right? Whatever you begin in this string which belongs to this language, right? Has to be what? Has to be part of L. Okay. All right. So again, a couple of more definitions over here. So again, so this is kind of repeating what we discussed, right? So L to the power 0 is simply an empty string. Okay, this is a definition that we're going to use later on. And L to the power n, right? So this is going to be another language, right? So over here again, any string in this particular language, right, can be broken down in this format, right? S1, S2, S3, all the way till Sn, right? Where each of the SI's belongs to L. Okay. So for example, let's say if you take this language right here. Let's say you take this, right? What happens? So you can say L. So L1 is simply this, right? Okay. So how about L2? So that means every word or every string in this language will be length 2, right? 2 alphabets, right? So what would this be? A, B, 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 right? Okay. Right. Okay. So again, so if you have 3, then you're gonna have more, right? L power 4, L power 5, right? You're gonna have more strings, right, in that set. Okay. So okay. All right. So so let's go over this style one by one. Okay. So I think there's a lot of stuff over here, but let's just go through this line by line. Okay. Yeah. 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 Yeah, the order matters. Yeah. Yeah. L has to come first. Okay. Okay. So let's see. Okay. So there are some. Here are some like some examples. Okay. So let's do this. So the first one right here. So what are the products? So let's say you have language L. Okay. And then so the question is what are the products L? This is the empty set. Okay. L empty set. Okay, so that's one question. Then, so what is the product of L with a language which only has an empty string? Okay. So how about this one? Let's discuss this one. This might be a little. Let's discuss the second one. What? So if you take a language L, and if you take a language which only contains an empty string, right? And if you want to define the product, right? So what would the result be? Is that?
L0.
No, so the empty, so that means, so remember, so let's see. So the empty string, right? So empty string is something like, if you take any string, right? Say you have CDD, empty string is what? CDD, right? Or I guess empty string CDD, simply CDD, right? Okay. So if you do, L, so let's say if you want to define this product, right? So what it means. So your language has to be something like, right, ST such that S belongs to what? L, right? And what? T belongs to what? This, right? Okay. So now, so that means T is always empty, right? And T is always an empty string, right? So that means it always end up being what? S, right? Okay, S belongs to what? L, right? So that means this is always L, okay? Right. How about this one right here? L empty set. What's that? Okay, what's your logic? Why? So what you say is this is empty. Is that what you say? Okay, so what is that? What's your logic? So okay, so I think okay, so let's see. So again, if you do something like this, right? So L. So if you want to get some definition for this language, right? So it would be, so this should be ST where S belongs to L, and T belongs to what? The empty set, right? But this definition is not valid at all, right? You cannot get any language that has this definition because there's nothing in this, right? There's nothing in the empty set, right? So you won't be able to generate any language like it. So it's an empty set. Okay. Okay. All right. So how about, okay? Let's look at this one right here. Solve for L in the equation. So here's a product, right? So let's say the first language contains what? The empty string AB, right? And then you have L over here, and the result is basically empty string AB, AA, BA, ABA, BBA. So what we need to do is we need to come up with what strings, or I guess what are the strings contained in this particular language L. So that means if you take any string from this, right, from this set, you should be able to break it down to what in this format, right? ST, right? Where S comes from what? Empty string A or B, or T would be what? Comes from L, right? So you need to, so let's, okay, so this, the problems that we're going to go through, right? So I think this will be a good mental exercise, okay? In the sense, you won't do any programming and stuff, but I think it would be kind of, it would basically kind of give, it will basically increase your, I guess, logical thinking, things like that, okay? But there's no programming at all. So, so let's do this together, okay? Then. Yeah, I think if I go a little further, then you won't be able to hear the audio very well. So anyway, so Okay, so let's do this. So you have something like this, right? A, B. What do you have over here? Empty, A, B. A, B, A. What else do we have? A, B, A. B, A, right? Okay.
BBA.
Was that?
BBA.
Sorry, what was that?
The last one.
Oh, the last one, BBA. Okay. So we need to find what is L, right? Okay, so L is going to be something like this, right? It's going to contain some, it's going to be a set, right? Okay. All right, so that means, that means what? What does it mean? So if you take this, right? Or if you take this or any of this, right? You can basically break it down into this format, right? ST, right? Where this is coming from what? This set, right? Okay. And then this T should be from L, okay? So this, let's just call this, let's call this M. Let's just call this A. Okay, so let's do it. I mean, there is no, I cannot give you like, say, a step-by-step, I guess, technique to, you know, get L, right? I mean, it's just, I don't know, it's logic, okay? So if you do more and more problems, then you kind of get a hang of it, okay? So let's see. So what do you guys think? What do I do here? What can I do, or what?
It's the alphabet of if T is inside L, then S must be
So okay. All right. So let's say so let's look at, maybe we let's just start from probably, okay, leave this for now. How about, let's just say A, right? If you take this A over here, so you need to express that in terms of ST, right? Okay. So it would be something like this, right? So A is, so it should always start with something which is in what? Here, right? So let's say you start with A over here. And then what do? It should end with something from L, right? So let's say, so you can put this, right? Okay. How about this one? Same thing, right? B starts with something from A, which is B over here. And this, right? Nice, right? How about this one right here? Starts with something from A, right? Which is A over here. So I'm just going to underline. So this is going to be from L, right? A. This can be what? Start with B, which is from A, which is from uppercase A, and then what? Okay, right? And how about this one right here? A starts with lowercase a, which is from the language uppercase A, right? And then this is what? BA, right? And this is, you can write this in terms of B, BA, something like that, right? So simply have to take it. So this is, so you can simply write this as what? Empty, that's right. Okay. So what you have to do, you simply have to take a, the union of all this, right? So L will be simply what? Empty string. A, right? Sorry, not A. Sorry, A, right? A and BA, right? Okay. All right. Okay, so so this is kind of, here we're just repeating what we discussed, right? But what we discussed a previous slide ago. So so LS3 is simply, you can there. So this is, the closer is just a fancy term. Okay, so you can instead of simply saying L asterisk, you can simply say the closer. Okay, the closer of a language L. Okay, all right, simply union of all these different languages. Okay. Okay, so let's see. How about, so let's look at one more question right here. How about this one? What are so what you need to do is, what is this, right? Empty string. Okay, so let's look at, so what is this and what is this? So how about this one right here?
It's just carrot.
Is this, so that means you, so okay, so if you have to apply this definition right here, right? This on this, right? So what would this be?
Itself.
Self, right? And so because you, so let's say if you take ln, right, on this, right, so it's simply, you simply concatenate n empty strings, right? So it's going to be empty. It's going to be simply empty. How about this one right here? What's that? Will this be an empty set? Oh, I guess, will this contain an empty string as the result?
It'll just be null. It'll be itself.
No, so okay, so let's look at it. So here, if you take this, right, so what you need is this, okay, so no, so this one, so this is what, this, all this is simply null, right? Okay. Because you cannot really have definition on this, right? You won't be able to come up with this kind of definition right here. Okay. So here, so how about this right here? Empty set.
That'll result in
Empty string.
empty, yeah, and then empty null.
No. So this would be, so okay. So for this one, so, okay, by definition, so by any set, right? Any set rest for 0, right? It's basically empty string. So any set rested for 0 is empty string. Okay, it doesn't matter what this is, whether it's null or A or B or whatever. All right, so I'll put up some notes, okay, on all these questions here, on Blackboard, okay. Of course, whatever. Every time we have some question like that, I'll put up some notes, okay. All right, so let's. So the next series of lines is simply kind of will help you understand the definition of product of two languages, okay. So let's just go through this line by line, okay. So yeah, there's a lot of words over here, but let's just go through this line by line. Now, okay, so here, right, so what this is asking is, okay, can we try to understand this particular string, right, x, which belongs to this language, right? Okay, so the closer of this is simply the product of what L, closer of L, and then you take the product of ML and then take the closer, right? Okay. So that means if you take any string x, right, which belongs to this language, this whole language over here, so you can simply express in terms of what? UV, right? So where U comes from what? First language, and V comes from second language, okay? All right. Then what do you do? You further break it down, right? So now you break down U again, right? So here U belongs to closer of L, so that means what? So you use either an empty string or what? A combination of different strings that belongs to what? L, right? Okay. Now remember this, so n can vary, n can actually vary, right? So n can be 1, n can be 2, n can be 3, whatever, okay? All right. And so again, so now we have U over here. So U is in this format, right? U can be either an empty string or simply a combination of different strings from L, right? So the number of strings or number of S can actually vary, right, depending on what n is, right? So n is 1, it's only 1, right? N is 2, there are 2, right? Okay. And then what we have over here is if you wanna break down V again, right? So V belongs to ML, closer, what does that mean? So it can either be an empty string, okay, or it can be in this format, right? So here, so you have ML, right? So the first string has to come from M and second one has to come from L, right? So you have R1, T1, okay, TK, right? All right. So now if you kind of summarize everything, what you're going to see is, let's see. So you have U, so X is UV, right? So we have U empty, V empty, right? So that means this X is going to be either empty, okay? So what I mean, so if you simply do this, right? Okay, let's do this. Let me do this. So S is basically, sorry, X is basically UV, right? So what you use, so let's say you take U empty, and then you take V empty, what do you get? You get empty, right? What if you take U to be this, okay? S1 all the way to Sn, and V to be empty, what do you get? You get this, right? Okay. And what if you take U as empty, and you take what? V as this, right? Then you get this, right? And then what else? If you take U to be this, and take V to be this, right? You get this, right? Okay. Just yeah, it's just I got kind of breaking down this particular string X. Okay. Okay. Logically, okay. All right. So all right. So let's see. So this one, the last line, I'm just gonna, yeah, it's just definition, I think. Yeah, it's not a big deal. Okay. Okay. So let's start talking about grammars. Okay. So this is when it gets more interesting. So. Okay. So the slides are basically based on chapter number 3 from this book, okay, from Discrete Structure, Logic, and Computability by James Hine. So, all right. Okay. So what we're gonna do here is this. Okay. So let's say if you have, let's say you're given a particular language, right? So most of the time, what we're going to do is we're going to come up with some grammar, or I guess a set of rules that you can use to generate that language. Okay. So today what we do is we'll go through a few examples and kind of define grammar in terms of computer science. Go through some examples, and then next week on Monday we'll also do more examples. Okay, just to kind of give you guys a hang of it. Okay. All right. So, all right. So grammar is simply what? Just in general, what is grammar? You have to follow a set of rules, right? When you write a sentence, or when you write some article or whatever, right? Okay. So in computer science too, grammar is going to be the same definition. Okay. But in computer science, it's going to be a set of rules that you use to generate a particular string. Okay. That we'll see later on. Now, okay, so a very simple, I guess, grammar in English language is basically when you define a particular sentence, right? The grammar or the rule that you need to follow when you define a sentence. Okay, so for example, if you have a sentence like this, right? The big dog chased the cat, or something like that. Okay, so here are three simple rules, right, that you can follow to basically write a sentence. Okay, so let's say the first was, so this rules might not be complete, but I think this will illustrate the concept of grammar a little bit. Okay, so now you say, okay, sentence, right, so it should have a subject and a predicate, right, something like that, right? So then what you say is, okay, the subject should be followed by predicate. Okay, so that's one rule. And then what you can say, okay, the subject can be an article followed by either a noun or an adjective. That's another rule. So over here you have, so the big dog's basically the subject, right? And then chase the cat is the predicate, right? And then, so the predicate can be a verb followed by an object. Okay. Now, okay. But the concept is this, okay? This is a concept right here. So, how many have taken CS3, the data and information structure math? Yeah. So if you've taken that, then you should be able to understand the concept of trees. Okay. But how many haven't taken CS3? Oh, everybody's taken CS3. Good. Okay. I don't have to worry about trees and stuff like that, right? Okay. So now, all right. Now what you can do is this. You can basically represent, I guess, this set of rules, right, using a tree. Okay. So that means whenever whenever a sentence comes, okay? So it can either be what? Or I guess whenever a word from a sentence comes, it can either be a subject or predicate, right? So let's say the subject, right, it goes over here. Then you ask the question, is it an article, an adjective, or a noun? So depending on what it is, it goes, right? It goes in one of those branches, right? Okay. And then, so if the word is a predicate, it goes over here. So is it a verb or an object, right? It goes over here, right? If it's an object, it's an article or a noun. So that means any word in the sentence, right? If you feed that word in that tree, what happens? It always end up at one of the leaf nodes, right? Okay. All right. So let's say if there is a particular word, right? Which doesn't follow the rules of the sentence, right? It will not basically end up in the leaf node. It would basically stuck somewhere here, right? Either here or here, right? Okay. Now, so we're gonna discuss more in detail about parse trees later on, okay? But this is just kind of illustration of a simple grammar, okay? Now, let's see. All right. So what we're gonna see later on is something like this, okay? A lot of this, I guess, notations, okay? So where we have a sentence over here, so a sentence can be a subject followed by predicate, right? The subject can be replaced by an article, adjective, noun. The predicate can be replaced by a verb or object, okay? So we'll go through the definition of what this arrows means, okay, later on, okay? But ultimately what we're gonna do is you're gonna define, or I guess you're gonna set up a grammar in this format, okay? So these are basically, these are simply rules, right? That allows you to basically create this tree, okay? This parse tree. Okay, so, all right, more words, okay? So, okay. So what I want to do is before I start talking about, I guess, the formal definition of grammar, okay? What do you need? What are the minimal requirements that you need in defining a grammar? Before that, I just want to go through, I guess, some terms, right? Some definitions, okay? Okay. All right. So let's go through this, okay? So ultimately, what we're gonna talk about grammar in terms of rules, okay? Or these rules are basically called productions, okay? So you can simply use this set of rules to produce any string which is a part of that language, okay? Now, so again, so we're gonna have one alphabet, okay? Which we usually notate by uppercase A, and the language is gonna be denoted by uppercase L, right? Now, okay. So this is what we're gonna see, okay? So let's just do like this. So what we're gonna later see is this. So this production rules, okay? This production rules is gonna be something in this format. So you're gonna have some symbol over here, and then an arrow over here. Let's say some symbol over here, or like let's just say A, some symbol over here and B. Okay. Okay. So these are symbols. Okay. They are not really the characters in the alphabet. They are the symbols. Okay. Now, or I guess you can do that. So a grammar is going to be simply a collection of this. Okay. So there can be multiple production rules. So each of these is simply a production rule. Okay. So a grammar is going to consist of multiple of this, okay? Multiple production rules. Now, so when we write something like this, okay, so alpha, the arrow, beta. So what it simply means this. So the symbols is going to be, they're going to be strings over alphabet or terminals. Okay. So this is, okay, let's do this. So what we're gonna, so let's just try by a little bit. Okay, so let's say A is A. Okay, so let's say this is the alphabet A, B, right? So so A and B is simply terminals, okay? So when I say terminal, that means you cannot replace, right? So these are these are the exact characters in alphabet, right? You cannot really replace them by anything else, okay? So once you reach this, that's the end of the string, okay? You cannot simply expand the string later after that, okay? So now, so what you can also see is something called non-terminals, okay? So non-terminals are basically just symbols which are not a part of the terminals, okay? So you're gonna use something like, say, S. So there's gonna be different symbols, okay? B, C. Okay. And what you can do is you can basically, later on, you can replace any of this by a group of terminals or a group of non-terminals. Okay, so when we get to the definition, it becomes more clear, okay? So, so once your string ends with a terminal, right, you cannot really expand the string, okay? But if it ends with some of this non-terminal, you can simply expand the string. Okay, so we'll see that in a bit, okay? Now, so but the basic point of this slide is this. So so when I write something like this, right, alpha, the arrow beta, it's simply you can simply read it this. Alpha produces beta, or alpha derives beta, or alpha is replaced by beta. Okay. All right. So when I say something like this, right, alpha, the arrow beta, it simply means alpha produces beta, alpha derives beta, or alpha is replaced by beta. Okay. Okay. Again, so one more thing. So there's every grammar, you're going to see that there's basically a start symbol, okay? A special symbol called start symbol, which is usually denoted by uppercase S, okay? And then, so remember, so you need to have a start symbol, otherwise you don't. I mean, how do you begin a language, right? So that's why you need to have a start symbol in any language, okay, or a grammar, okay? And then another definition, sentential form is simply a collection of strings, okay, which are terminals and non-terminals. Okay. So these are just simple definition. Okay. So let's do this. Again, we haven't talked about the formal definition of a grammar. Okay, but I'm just going through some examples. Okay. All right. Okay. So here, let's say I have a alphabet over here, right? Which consists of 3 different characters: A, B, C, lowercase a, lowercase b, lowercase c, okay? And then what we have over here is this, okay? So let's say you define the language, okay? Closure of L, which is simply union of all of this, right? So now the language simply consists of all these strings, okay? Now if I want to come up with a grammar that basically represents this language, it would look something like this. Okay, so don't worry about how we come up how we get this from here, okay? So we'll go through some example that will kind of help you understand this, okay? But so what I'm saying over here is, given any language, right? If you want to set up a grammar for that language, the grammar is going to look something like this. This is simply a set of production rules, right? Now, just to kind of I guess enforce the concept of production rules, right? Let's go through this. Let's go through these 4 rules, okay? So okay, so when I have something like this, right? So that means if I take any string from this language, okay, I should be able to generate that string using these rules. Not just one rule; it can be a series of rules, different combinations. You can use different combination of these rules, okay? All right. So you can use multiple times, okay? And other thing is, so the first thing is that if you take any string from this language, you should be able to generate that string using these rules. And let's say any string that you generate from these rules should be a part of this language. So that means let's say you use these rules and get a particular string, right? If the string is not in the language, this is not the grammar for that language. Okay. All right. Okay. So what I mean by that is this. So let's say you have this, right? That's a start symbol. Okay. So remember, so when you write S produces empty string, what it means? S can be replaced by empty string, right? So that's a start symbol, okay? So empty string is going to be a part of the language. Okay, so that's one way of generating empty string. Now let's say if I do this, okay? Let's look at the second production rule. S is replaced by A S, right? So that, what does that mean? So that means you can, so there are different ways. Let's say you can do this, right? S can be replaced by, so you can simply use this rule too, right? Yeah. So that's, so this ends up the string to be what? A, right? Okay, the other thing you can do is this, right? So let's say you have this, right? So S can be replaced by what?
Empty.
Empty. It can be also replaced by what? AS. Okay. Now it can also be replaced by what? PS, right? It can be replaced by CS, right? Okay.
How come A is on there twice?
What's that?
How come it's A, B, C?
Oh,
S?
so it's okay. The first step is this. Okay, let's start. So you have this, right? So let's say you do something like, so we'll talk something called derivation step. Okay. So the first step what you can do is you can do this, right? S is replaced by what? AS, right? So you have A over here. You can replace by AS. What do you have? AS, right? So this A is from here.
Be replaced with AS.
No,
If
no,
you're
no.
doing it in that situation, S can be replaced with AS. S can be replaced by empty, and then.
No.
Sorry.
No. So okay, so when, let's say I start with this, okay? Let's say I start with this, okay? Let's say I start with this. Okay, maybe I'll just use a simple example right here. Okay, so let's say A. Let's just say A. Let's just say A. Okay, like that. Okay. So let's say this particular string is going to be a part of this language, right? Okay. So now if this is the grammar of that language, right? Then I should be able to what? Generate this from using this, right? These rules, right? Remember, you cannot. You can use multiple rules. You can combine different rules. Okay. It's not necessarily you just use one. Okay. So let's say you start with this. Okay. Let's say you start with this. Okay. That's the obvious way to start because it starts with A, right? So let's say you start with A S. AS, right? So now your string is what? AS, right? So remember, you can still expand this string. Why? Because this is not a terminal string. Okay. So what is the next logical step to do? If you want to go from here to here, you can use which production rule do you want to use?
Study
This one, right? Okay. Does it make sense?
Yeah.
Yes. Okay. So now, so you replace this by what?
AS.
AS, right? So we have A. That's right. Then what do you do next?
They can replace it by S again.
Yes, again, right? Then now what do you do?
And then S can also be equal to
Empty, right? So use that rule. So you have. Okay. All right, so get the idea of the production rule a bit. Okay.
But why do you do it twice for the one you were doing before?
What do you mean twice? This one?
When you were doing AS and then you did AS again and then BS and CS.
Oh, that one just okay. So let's say, for example, if you do this, right? If you want to generate this string right here, AA, B, or AA, B.
What's-
Yes,
Okay,
that's-
all right.
If you want to generate this string, what do?
You do AS twice, then BS.
Then you do B,
CS, and
BS,
then
right? So then you have B over here, the CS, right? Then empty, right? Okay. So you can use the combinations, the rules in different ways, right? Okay. Now remember. So remember this. So this is non-terminal. This is one of the non-terminal strings, I guess, symbols, right? So that means you can. So the purpose of non-terminal is simply expand the string, right? Okay. If you simply end with end like that, there's no way, right, of expanding the string. Okay. All right. Okay. So yeah. So this is, I guess, yeah. This will kind of be very good mental exercise. Okay, for at least to kind of go through this process. Okay. Not really programming, but yeah. Okay. So let's see. So let's kind of go through the definition. Okay. Let's go through the definition of grammar. Okay, I guess the formal definition. What goes into the grammar? What do you need, right? Okay, so first you're gonna have the set of I guess symbols or characters in your alphabet. So these are basically the terminals, okay? All right. Then you're gonna have non-terminals. These are just symbols, okay? So the non-terminal usually have the start symbol and other symbols, okay? So usually they are basically uppercase, okay? So implicitly later on they can be simply replaced by, ultimately they're gonna be replaced by a group of terminals or non-terminals. Okay, for example, here you see, right? S is replaced by what? AS, right? Or it can be replaced by empty, or it can be replaced by, let's say there might be a symbol, some letters, right? Okay, so it can be replaced by a group of terminal, non-terminals, okay? Okay. Now, so the start symbol, okay, so so in the production rule, in the collection of production rules, there should be one production rule where the start symbol is on the left. Okay. Otherwise, you won't be able to start even build the language, right? If you don't have the start symbol on the left of the production rule. Okay. And then okay, so let's go through this one by one. Then you're gonna have a set of production rules. Okay. All right. Now, okay, so let's do this. So the production rule is gonna be in this form, right? Alpha produces beta, right? Okay. Now, so this symbol is going to be simply, I guess, an item in this set, right? N union. N is basically the terminal and non-terminal symbols. Okay. So over here, symbol alpha and beta, it can be any of the terminals, or sorry, it can. Hang on. Yeah. So it should be something from this set. Okay. Set of terminals and non-terminals. Okay. And then obviously with the restriction that so this cannot be empty string, right? The one on the left cannot be an empty string at all. Okay. So this is just repeating, right? So there should be at least one rule with one production with the start symbol on the left, right? Okay. So you're gonna use that to basically start building your language, right? Okay. Now then again, each non-terminal must appear on the left side of some production. So that means, so each non-terminal should appear on the left side of some production. Okay, so that means, so what does that mean? So let's say for example, you have a non-terminal, let's say S over here, right? Or let's say you have some non-terminal T, okay? So remember the whole purpose of non-terminal is simply to expand your string, right? So if you don't have a production rule for this, right, or on how you replace T, then you won't be able to expand, right? So that's why you need a rule with T on the left hand side. Okay, so you need some rule that allows you to define, okay, how do I replace uppercase T? Okay, all right. So but usually so when somebody asks, okay, write a grammar for this language, right? You don't kind of say, okay, terminals this, non-terminals are this. You don't do that. You simply write the production rules. Okay, so from the production rules, you should be able to extract all this information, right? What are the terminals? What are the non-terminals? Start symbol and all that stuff. Okay. Now, all right. So let's do this. Okay. So here's example. Okay. So here is a set of production rule. Okay. Here's the grammar over here. Now over here, so you can see everything which is basically uppercase, right? They're basically non-terminals. So here is S, B. Okay. Terminal is basically lowercase a and b, lowercase a, lowercase b, right? So this is basically sufficient. Okay, this 1, 2, 3, 4 this 4 production rules are basically sufficient, right? To simply say, okay, this is the grammar for a particular language. Okay, so you don't have to write non-terminals, terminals, all that stuff. Okay. So or I guess you can also write this in this format. So that means, so you have over here S can be replaced by ASB, or S can be replaced by empty string, right? So you can simply say S can be replaced by ASB, or, so this simply means or, right? Empty, okay. Or over here you have B, B can be replaced by lowercase b, B can be replaced by lowercase b, uppercase b, right? So, or, okay. Now you see over here, so the non-terminals, right, S and B, so there's at least one production rule, right, with S and B on the left-hand side, right? Okay, so then there is one production rule, at least one production with S on the left-hand side, right? Okay. Now, okay, so I think, okay. All right, okay, some more definition, okay. All right, so this, yeah, I kind of briefly mentioned this, but let's do this. So derivation, okay. So the concept of derivation is this. So let's just try to understand this with an example, okay. Now let's say if I have this, okay, I have this production rule. Okay. Here there are 4 production rules, right? So this is going to be a grammar, right? Okay. Now let's say let's say you have this string over here, okay, A, B, 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 okay. So that's going to be a string, which is a part of the language built by this grammar, right? Now what you can do is this: you can basically start up with one production rule. You can begin with one production rule, right? And then kind of derive from here. You can so let's say you use the first production rule over here. S is replaced by what? ASB, right? Okay, let's start with this, okay? And then you kind of go through a series of steps until you reach the final string that you want. Okay. So over here you start with S is replaced by ASB. What do you have next? AA. So here the middle S over here is replaced by what? ASB, right? Okay. Then in the next step, what is this? S is replaced by what? Empty string, right? And then what do you have over here? From here to here, what is this? You're using the rule BB, right? And then again, uppercase B is replaced by lowercase b, uppercase B, right? And then finally, B, uppercase B replaced by what? B, right? Okay, so basically, this series of steps is simply called derivation. Okay, so basically the steps that you follow, right, to reach a final string, okay, is simply derivation, right? So I mean, each step has to follow one production rule, right? So that means over here, this one you're following what? This rule, right? So from here to here, you're gonna follow one rule, right? Another rule, okay? You can choose any rule, okay? Right? Now, okay, in this particular case, it's basically leftmost derivation. What it means is, at any point, right, what do? You basically choose the leftmost non-terminal, right? And apply a production rule in that. So that's what's happening over here, right? So you have you get ASB, right? So then you choose a leftmost non-terminal, which is, in this case, what? What? What's the leftmost non-terminal in this string, Anthony? In this ASB, which one is it? What's the leftmost non-terminal? S, right? So then you choose that, you apply production rule in that, okay? So you have so over here, what you're applying. So from here to here, what production rule are you applying, Anthony? So you're applying what? S is replaced by what? ASB, right? Okay. So what I mean by that here is the leftmost derivation. You choose the leftmost non-terminal at any step and then apply a production rule. Okay. So leftmost derivation. Okay. You can also do rightmost derivation where you choose the rightmost, I guess, non-terminal and apply a production rule in that. Okay. So again, the different symbols. Okay. So there are a lot of symbols, right? Yeah, all this math people, they have any math major here? No? Okay. Then we can talk about them a little bit. So here, okay. So let's say, so this derivation over here, right? So this one actually has, So you have 1, 2, 3, 4, 5, 6 different steps, right, to get to this, right, from starting from here. So so if you have a derivation, right, which consists of I guess several steps, you can simply denote by either this symbol or this. Okay, so this would simply means the derivation contains at least one step, right? Okay, so this symbol with a plus sign, it simply means that there is at least one step involved. Okay, right? Now this simply means there's basically 0 or more steps. That means from here from okay, so here, so let's say from if I simply do it, let's say, so let's say it's this, right? Let's say if you want to generate the empty string, right? Okay, so what do? You can simply do this, right? Okay. Now, if you want to do, let's say, let's see, you could do. So if you do something like this, right? If you do something like this, S gives, let's say here. Let's use this particular string over there. S. Let's use this string. I'm trying to find a string over there. So yeah, let's just come up with, let's say there's some string over here, right over here, okay, that belongs to a language, right? So you can, so you know, from here to here, right? So what you can do is you can either go directly, right? So there might be a production rule that simply allows you to go from here to here, right? Or in order to get from here to here, you might have to use more than one derivation step, right? Or I guess more than one step. Okay. So if you can simply go directly, right, then you can simply use this, right? Or you can, if you go at least one step, then you can simply use this. Okay. This symbol, different symbols. Okay. But the whole point is this. Okay. So when I say a derivation, right, that means so there's going to be a target string that you want to achieve, right? So in this case here, then you're going to have your start symbol, right? So basically, in order to go from the start symbol to this, so you're gonna simply apply one production rule at each step, right? So all those steps simply, so the steps that you take to go from the start symbol to the target string is simply derivation. Okay, that's it. Okay, so we'll basically denote by this symbol. Okay, each step will be denoted by this symbol. That's what it means. All right, now. All right, so let's look at this. So examples, okay. 11 o'clock, okay. So okay, so let's say so in this case, where this example simply allows you to understand. So let's say if you're given a particular grammar, okay. So can you kind of explain the language which is generated by the grammar, okay? So over here, what do you have? So you have S is replaced by ASB or empty string. And then B is replaced by lowercase bb or just lowercase b, right? Now, if you try to understand the language by simply looking at this, right? You won't. So I mean, by simply looking at production rules, right? You won't be able to kind of understand the language, right? So what you have to do, you have to kind of apply these production rules, right, and generate some examples. Okay. So from the target strings, right? From the example target string, you should be able to find some pattern involved. Okay, so over here, so let's do this, okay? So over here, what do we have over here? So let's go through this step by step, okay? All right, so over here, you have, so the production rules are S is replaced by what you have here. ASP, you have empty string, right? I mean, obviously, the simplest string that you can generate is simply the empty string, right? Okay, so you do this, right? Okay, what else can you do? So let's say you take, let's do another rule, right? Let's say you have SB, sorry, ASB, right? Then what do you do here? So then you can apply another function rule, right? So let's say you apply on S, right? Let's say you take this, right? So let's say you be what? AB, right? Okay. Then let's say you choose to apply this rule over here. You're gonna get what? AB, right? That's right. So again, let's say then you now that's not the end, right? So you can do something like that, right? So let's say at this point, what do you do? You can apply this rule, right? So what do you do then? The A S replaced by ASB, right? So B one. ASB, B, right? Okay. So then here you can apply the empty string, right? So it'll be A. Then you can apply B, right? Okay. So it'll be A, B, right? Something like that, right? So you can kind of, I guess the basic idea, okay, you start with something simple, right, and then kind of go from the simple derivation to more and more complex derivation, right? That's what you do. So then, if you do some series of derivations, example, right? So what you're going to see over here is these are all the target strings, right? So you have empties over AB, you have ABB, AABB, you have AA, BB, BB, right? So now, so you have to come up with some general representation for this particular language, okay? So then now, so what do you see here? From this, and this. So what can you see any pattern? What pattern can you see? So those are all strings, those are all strings in the language which is generated by its grammar, right? Okay. I mean, those are not all the strings, but this is just the sample, right? So what do you see here? So always starts with A, right? A or empty string. Always ends with B, right? But there can be what? So okay. So let's see more. Okay, so let's see over here. So if you see over here, right? So it empty, then here. So you have A, B, right? So there is not. So A, B over here. Then what do you have? A, B, 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 right? So that means if there is one A, there is one B, right? If there's one A, there has to be at least one B, right? Something like that, right? So over here, what do you have over here? So you have A. So there's nothing like there's not a what do you say? So if there's an A, right, there has to be at least a B, right? Or if there are two A's, right, there should be at least two B's, right? So for example, here there are two B's, two A's, two B's, at least two B's, right? But there can be more than two B's, right? So ultimately, what you're gonna do is this, right? So let's say you do something like this, right? So it's so this is simply like this. Let's say it starts with A, right? So let's say you do A, right? Okay, then they say it ends with B. Okay, all right, and then say okay. So you need to take care of the empty string, right? Okay, and also let's say now the string in the language, right, can begin with multiple A's, right? So let's say you do multiple A's can be taken care of A to the power n, right? So n can be, if n is 0, it will be an empty string, right? Okay, let's say n would be what, 0, 1, 2, whatever. Now, but if you have n A's, right, you should also have n B's, right? So that's why you have over here. So when n equals 0, what? This is empty, right? Okay. So that, but there can be more n B's, right? More B's than n B's, right? So you have plus k over here. Right? So k, what k is also this, right? Okay. Right. So I mean I don't know any. You cannot. Yeah. So you won't be able to write a program to get this. Okay. But it's just kind of, I guess, trial and error or something like that. Logic. Okay. if you can write for, let me know. I mean, just general, like, just because you won't, I mean, you won't be able to, let's say, I mean, perhaps you can write it. You can probably write a computer program to get maybe say a sample of string from the language. You should be able to do that, I think. Okay. All right. So okay. So let's do that. How about this one right here? So so don't worry about a solution over here. Okay. So let's just look at it. So describe the language of the grammar S is replaced by lowercase a, or S is replaced by BCS. Okay. So here's the solution. One option, we can just look at it and then go to the next slide, or we can try to understand it. Okay. so let's try to do this. Okay. So what you can do is, the first step that I think you can do is kind of generate some examples using the grammar. Okay. And then kind of look at those examples and try to find a pattern. Okay. That might be the general step. Okay. So what time is it? Okay. So let's see. So I don't think we'll be able to finish this. Okay, so here, so you have S, this, right? And S. Okay. So the easiest thing is this, right? Simply this, right? Okay, that's the easiest, right? Now let's say if I do this, okay, so S, use the second production, what do you get? BCS. Okay. What you can do is BCK, right? Okay. Or what can you do? Yeah, you can do this, right? BCS. Then you can again replace S by what? BCS, right? So it would be what? BCS again. So that would be, so then you can replace S by A, right? Because there are only two options. You can replace S by A or BCS, right? So you replace. So what do you get here? BC, A, right? And then you can kind of continue this, right? So let's say instead of replace S by A, you can get this all the way here. What do you do here? BC, S, right? And then replace S by A, what do you get? BC. Something like that. So what do you do? So if you think a little hard, right? So what do you get here? So that you see here, it always ends with here, right? So and A here, A here. Okay. Begins with either there's nothing either here, or what do you have? Or you have a series of BCs, right? BCs, right? So BCs always together, right? BC here, two BCs here. Sorry, two BCs here. Yeah, three BCs, right? Okay, so it'll always end with A, right? And over here, so always begin with BC, but there can be more BCs, right? Zero or sometimes, right? Zero or more than zero. So let's say in it's going to be either 1, 0, 1, 2. So I think, yeah, I guess the general step is going to be like try to generate some examples, and then if you can see some pattern, right? Try, yeah, some kind of patterns should definitely work. Yeah, but it might, yeah, I think it would be kind of hard to just look at the grammar and try to come up with language. It might, so you have to, yeah, I think I can't do it. So if you're able to do it, that's fine. But I would suggest you just try to get some examples and try to see some patterns. So there are some notes over here. You can look at this later on. Okay. You don't, okay. So, okay. All right. So in the next, let's look at this. We have, okay. So let's see if so here in this slide, what we're doing here is kind of, okay, give a grammar, try to get a language, right? So how about here in this, so what here is you're given a particular language, and you have to come up with some kind of grammar. Okay. All right. so let's try. So there are some simple examples over here. Okay, so I have some notes over here. Okay, more notes over here. So let's try to understand this. Okay, so here there are 3 examples. Grammar of A. You have a language A for NB. So N belongs to N is a natural number, right? So N can be 0, 1, 2, whatever. Okay, then you have over here B A N. Okay, or you have A B N, right? So if you try to look, so again, try to get some examples first. Okay, so let's say the first case over there. So let's say, so let's say A and B, right? A and B. So that's your language, right? So you have to come up with a grammar for this, right? So let's just try to get some examples, right? Example strings for this language. So N, when N is 0, this is B, right? What else? N is 1, A B, right? N is 2, A B. So A. Sometimes, right? So it's gonna. So that's going to be some examples stream from the language, right? So remember, so to define a grammar, right, you're always going to have some kind of start symbol, right? Okay. Okay. So remember, so here the terminals are what? A and B, right? So this is going to be this is your alphabet, right? So now. So again, there's no like a strict step-by-step here. Okay, so what would be the first easiest reduction rule? You can just start with something easier. If it's wrong, you can come back and change it. So you have to go through that process. I guess what would be the easiest rule? So if you want to generate this, what do you do here? That's P, right? Okay. So now, so next, what do we do next? So let's say what we need is this, right? So what this is taken care of, right? So what we need is we need to come up with something, right? Some rule or make one rule or several rules to get all this, right? Now, like, most of the time you should be able to get, I guess, use a pattern, right? And then kind of simply replicate the pattern using the production rule. Okay. So over here, what do you see over here? So over here, I mean, now you see, okay, there is A over here. No, there's A over here. So there's 1 A over here, there's 2 A's over here. Okay, well, yeah, 3 over here, there are 4, right? So, so what would be some options I guess you can try?
S could be A, and then S could be empty.
Okay, so what is that?
I was thinking S could become SB, and then S could be empty, and S could be A.
So let's say S could be what?
SB.
SB, okay.
And then also S could be A.
A. Okay. Oh, you mean S empty like that?
Yeah. And,
okay.
Yeah.
Okay, so you try to come up with some rules. So what you can do is you can say, okay, you can ask a question, are these valid, right? So if I simply choose, let's say try to, let's just go through this process, okay. So how about this one? Is this valid or not? Can this be a valid rule? Remember, if you use this rule, what do you get? What string do you get? Empty, right? Is empty a part of the language?
No.
No, right? So let's say, okay, I don't need this, right? Oh, this one right here.
No, that's not.
No, right? How about let's try to use this, okay? So what do you get over here? Let's say, so this is already there, right? So, okay, now, so what do you do over here?
You just get BB.
You get B, right? BB, right? Or you can get BB, or you can get what?
SBB.
SBB, right? So when you're getting, you don't get A at all, right? Yeah.
It's kind of like the previous example where like you need like a rule to kind of like just
So you should be able to the rules with the rule you should be able to kind of expand your string. Okay? So
one of the rules be like, you want A to repeat.
Yeah, so you want A there, right? So what
Yeah.
you can say, okay, what if I try this? Because obviously there's going to be A, right? You can simply say A, and I do this, right?
Right.
You can just try it out, right? So so what if I use this one? Let's say this will work. So how about this one right here? Let's say if I choose this, right? What happens now?
So this is
BA, right? So you can be BA or AB. It's going to be BBB A, right? So that's one all we want, right? How about this one right here?
you want that.
So it can be AB, right? Or it can be what? Right?
That's the one.
This way, right? So yeah, so you have to kind of, I guess, try different ways. Okay? So kind of try different possibilities. Remove one non-valid. Test different things. Yeah. But the first step is kind of write up some example of it, so you can see the pattern. Okay? So all right. So there are some notes on the next slides over here for this, so you can kind of just kind of go through the thinking process a little bit. So then on Tuesday we'll yeah, we have to finish combining grammar and things like that. Oh gosh, we didn't even finish half of it. Okay, so yeah, let's. All right.